students, welcome to Vari Medical Academy. So, உங்களுக்கு எல்லாத்துக்கும் ஒரு குட் நியூஸ். Vari Medical Academy சார்பாக இனி வரும் நாட்கள் டெய்லியும் ஒவ்வொரு டாபிக் நம்மளுடைய faculty members லைவ் வீடியோ ஸ்ட்ரீம் உங்களுக்கு கொடுக்க போறாங்க. Wish you all the best my dear future doctors. டாபிக் ஏதாவது வந்து கிளாரிட்டி வேணும் அப்படிங்கிற எந்த கண்டென்ட் ஆனாலும் கமெண்ட்ல தெரியப்படுத்துங்க. அதுக்குண்டான சொல்யூஷன் Vari Medical Academy சார்பாக கொடுக்க ரெடியா இருக்கும். இந்த மாதிரி வீடியோக்கள் உங்களுக்கு பிடிச்சிருந்தா மறக்காம லைக் பண்ணுங்க, சப்ஸ்கிரைப் பண்ணிக்கோங்க.
Hi, I am Kiran Kumar Reddy, chemistry faculty from Vari Medical Academy. Today concept hybridization. Hybridization. In last video I explained ionic bond, lattice energy and Lewis dot structures and valence bond theory. Next one is the hybridization. And what is hybridization means? Atomic orbitals of same or nearly same energy intermixing to give new hybrid orbitals of exactly same energy, that is called hybridization. What is hybridization? Atomic orbitals of same energy, nearly same energy intermixing to give new hybrid orbitals of exactly same energy, that is called hybridization. In valence bond theory, what we have observed in valence bond theory, the carbon, the ground state electronic configuration is 1s2, 2s2, 2p2. This is the ground state electronic configuration of carbon according to the VBT, valence bond theory. Now ground state is 1s2, 2s2, 2p2. Now first excited state in carbon, one of the electron jumped from s orbital to p orbital. Now electron jumping from s orbital to p orbital. Now here 2s2 means 1 is present in 2s2 1. Here is 2p3. Here is 1, 2, 3. This one is a px, this one is py, this one is pz. Now how many electrons are present? 4 electrons are present. Now hydrogen atom of 1s1, here is 1s1, another 1s1, here also another 1s1. Here they are overlapping like this, overlapping to form, all bonds are equivalent. Now this one is s orbital, 1 s orbital, 3 p orbitals are involved. That is the valence bond theory. According to the valence bond theory, all bonds are in tetrahedral equal. The bond angle is 109 degree 28 minutes. According to the VBT, explained like this. But according to the hybridization principle, what they are explained here, hybridization of filled orbitals and fulfilled orbitals and empty orbitals are involved. Who are involved? Off-field orbitals, fulfilled orbitals and empty orbitals are involved in hybridization. They are intermixing. Now, here is new hybrid orbitals experience less repulsion. This is the another point from hybridization. Next one is new hybrid orbitals is equal to number of intermixing atomic orbitals. Now, off-filled orbitals, full-filled orbitals, empty orbitals are involved in hybridization, and VBT only off-filled orbitals with opposite spin only involved in VBT. And according to the hybridization, empty orbitals also involved. Empty orbitals also are involved. New hybrid orbitals experience less repulsion. Next one is new hybrid orbitals. Hybrid orbitals is equal to number of intermixing atomic orbitals. And next one is, and the hybridization is responsible for geometry. Hybridization is responsible for geometry. Write down. Hybridization responsible for geometry of the molecule. This is the one of the hybridization. Next one is a hybridization. It explains only sigma bonds plus lone pairs. It explains sigma bonds and lone pairs. There is no explanation about pi bond. Hybridization is not explained about pi bond. Only it is responsible for sigma bond and lone pairs. Who are involved in hybridization? Atomic orbitals of same energy, nearly same energy orbitals are involved in hybridization. Now, hybrid orbitals are named after parent orbitals. Now I am taking one s orbital, one p orbital. They are intermixing to form two sp orbitals. This one is sp, this one is sp. One s orbital, one p orbital to form two sp orbital. If here z is equal to, we can write it 2. Now z is equal to 3 means one s orbital, two p orbital. They are intermixing to form 3 sp2 orbitals, sp2. Now I am taking z is equal to 4. Now one s orbital, 3 p orbitals are intermixing to form 4 sp3 orbitals. This one sp3, this one also sp3 orbital. That is z is equal to 4. Now here z is equal to 5. That is equal to 1 s orbital and 3 p orbital, 1 d orbital. They intermixing to form 5 sp3d orbitals. This one sp3d, remaining all are sp3d. This one also sp3d, this one also sp3d orbital, sp3d, and this one also sp3d. Now Z is equal to 6 means 1 s orbital, 3 p orbital, 2 d orbital to form how many? 3 plus 2, 6 sp3d2 orbitals are formed. Z is equal to 7, that is equal to 1 s orbital, 3 p orbital, sp3d3, 3 d orbitals to form. Here is sp3d2 hybridization, here is sp3d3 hybridization. Z is if Z is equal to 2 means 1 s orbital, 1 p orbital. What is the geometry? This one, this is a linear geometry, and Z is equal to 3 means trigonal planar, and Z is equal to 4 means tetrahedral. Z is equal to 5 means what is the geometry? Trigonal bipyramidal. Z is equal to 6 means octahedral. Z is equal to 7 means pentagonal bipyramidal. These are the hybridization. Sigma bond and lone pairs only are responsible for hybridization. There is no discussion about pi bond. Hybridization is responsible for geometry. Now shape of the actually s orbital is a s orbital spherical dumbbell, that is p orbital, and d orbitals is a double dumbbell like this, d orbital. But in hybrid orbitals, what is the shape of hybrid orbitals means we can denote it as like this. One is the smaller lobe, this is the small lobe, and next one is this one is the larger lobe. We can denote it as hybrid orbital, we can denote it like this, but s orbital, p orbital is like this only. Next one, hybridization. These are the important point. Hybridization is responsible for geometry. Sigma bond plus lone pair, only discussion about sigma bond and lone pair. There is no discussion about pi bond. Hybrid orbitals are named after parent orbitals. Here Z is equal to 2, Z is equal to 3. We can mix like it was 1s, 1p to form 2 sp orbitals. Next one is examples of, first one I am taking sp hybridization. Example one by one we can discuss. These are the important theory points about hybridization concept. Next one is sp hybridization. sp hybridization. sp hybridization. One s orbital, one p orbital, they are intermixing to form two sp orbitals, sp and sp. I am taking beryllium chloride, BeCl2. BeCl2 example of sp hybridization. Now beryllium electronic configuration 1s2 and 2s2. Now one of the electron, this is the ground state. This is the ground state. Now first excited state, here one of the electron jumped from s orbital to p orbital to p1. Here is one s orbital, one p orbitals of beryllium. They are intermixing to form, these are intermixing to form sp, 2sp. This is 1sp, this is 1sp. Now here is chlorine is there, chlorine electronic configuration 1s2, 1s2, 2s2, 2p6, 3s2, 3p5, 3p5. Here is the two chlorines I am taking, 1s2, 2s2, 2p6, 3s2, 3p5. Here last this p orbital, we can take 3 electrons, 1, 2, 3, 4, 5. Here also 1, 2, 3, 4. Now one of the electron, this one is overlapping this one, and this one is intermixing with this one to form the geometry. We can expect beryllium, this one, beryllium, 2 orbitals, one is the like that we can mention. And here is a pz orbital of chlorine. Here also pz orbital of chlorine. This is pz chlorine. Here is pz chlorine. Here this one is the beryllium. This is the sp. This is the one of the sp. The bond angle is 180 degree. The bond angle is 180 degree. Here is the first one. I am taking beryllium chloride. Ground state 1s2, 2s2. First excited state means one of the electrons jump from s orbital to p orbital. Here is two are intermixing, one s orbital, one p orbital mixing, two sp orbital. This is the one of the sp orbital. This is the one of the sp. One of the sp orbital intermixing with this chlorine. Another one is the intermixing with this one. Two chlorine atoms are there. Two chlorine. This is the geometry of the beryllium chloride. What is the geometry? This one is the linear. The bond angle is 180 degree. This is the beryllium chloride. If you take a hybridization of CO, what is the hybridization? Sigma bonds, number of sigma, 1 sigma, 1 sigma. And 2 means Z is equal to 2, that is equal to sp hybridization. This is also linear molecule. Beryllium chloride BeBr3, BeBr2. Here also linear arrangement. This is the example of sp hybridization. I am taking Sp2 hybridization. Next one is Sp2 hybridization. What is Sp2 hybridization? One s orbital, two p orbitals are intermixing to form three sp2 orbitals. I am taking sp2 hybridization. Sp2 hybridization. Here sp2 hybridization, one s orbital and two p orbitals, they are intermixing to form three sp2 orbitals. This one is sp2, this one is also sp2, and this one also sp2. Now three sp2 orbitals are formed. Now example I am taking. What is the example? I am taking BF3, beryllium boron trifluoride. Now I am taking boron electronic configuration, and here I am taking fluorine, three fluorines I am taking. Here boron configuration is 1s2, 2s2, 2p1. 1s2, 2s2, 2p1. This is the ground state. This is ground state. In first excited state, one of the electron jumped from s orbital to p orbital. Here is one s orbital, okay now, two p orbitals. Here p orbital means already one is there, one. Here jumping from here to here, here is one s orbital, two p orbital. How many orbitals are formed? 3 sp, 3 sp2, this one sp2, and this one also sp2. What is happening? Boron trifluoride I am taking. Boron electronic configuration is 1s2, 2s2, 2p1. Here is first excited state means one of the, this is not jumping, this one only. S orbital, one of the electron of s orbital jumping from s to p orbital. One s orbital to p orbital intermixing to form three sp2 orbitals. Now here also one sp2, sp2, sp2. Fluorine 1s2, 2s2. Electronic configuration is 1s2, 2s2, 2p5. The last p orbital I am writing. P orbitals 1, 2, 3, 4. Next one fluorine also 3, 1, 2, 3, 4. Here also how many? 1, 2, 3, 4. Now what is the hybridization? Intermixing, and this one is intermixing with this one, and this one is intermixing with this one, and this one is intermixing with this one to form. What is the geometry? Now I am taking, this one is the geometry, small size or big size. Okay, these are the Sp2, 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 3 Sp2. This is Sp2 and this is also Sp2 and this is also Sp2. And now pz orbital, this is px, py and pz. Pz, it will be intermixing with pz orbital. Here also intermixing, here also intermixing. This is the fluorine. Fluorine is the pz orbital of fluorine is our intermixing. And what is the bond angle? The shape, the geometry is trigonal planar, and bond angle is 120, all 120 degree, every 120, 120, 120, all are same, 120, 120, here also 120. This is trigonal planar. This is called Sp2 hybridization. Coming to the Sp3 hybridization. Sp2 hybridization example is boron trifluoride. Boron trifluoride. If you take what is the formula? The hybridization formula, later I will explain. Next one is the Sp3 hybridization. Sp3 hybridization. In Sp3 hybridization, Sp3, 1s orbital and 3p orbitals. 3p orbitals, this is p and p, to form 4 Sp3 orbitals. Sp3, this one Sp3, this one also Sp3, this one Sp3, Sp3 orbitals are formed. Now I am taking methane is the example. Methane, carbon electronic configuration 1s2, 2s2, 2p2. 1s2, 2s2. This is the ground state, na? Ground state 1s2, 2s2, 2p2, like this only. Next, in carbon in first excited state. In first excited state, what is happening? One of the s electron jumping from s orbital to p orbital. Now I am taking here also 1s2, 2s1, 2p3, because I am writing like this. Here is 1 s orbital, this one s orbital, 2s orbital, 2s, and here is a 2p3. How many is there? 1, 2, 3. Now 1s orbital, here is p orbital, p orbital, p. 3 p orbitals are intermixing to form how many sp3 orbitals? 4. This one is sp3 and this one sp3. This one also sp3, sp3. Here is 1, 2, 3, 4 sp3. Now, what is the here is hydrogen. Hydrogen atoms also there. Hydrogen 1s1. Hydrogen is 1s1. Here is hydrogen is 1s1. 1s1. They are intermixing 1s1. 1s1. Here also hydrogen 1s1. They are intermixing towards here is sp3s. This one mixing. This one mixing. This one mixing. Now, what is the shape? What is the geometry? Not a shape. Shape will be explained VSEPR theory, valency shell electron pair repulsion theory. Now, I am taking here carbon, tetrahedral geometry. Tetrahedral geometry. Here is one of the s orbital of hydrogen is intermixing to form sp3. This one is sp3. And this one also sp3, sp3, and this one also sp3, and the hydrogen is 1s1 of hydrogen. This is the tetrahedral geometry, and next bond angle is 109 degree 28 minutes. And next one is the sp3d hybridization. Another one is the Sp3d hybridization. What is Sp3d hybridization means? Here is I am taking Sp3d. Next one is Sp3d2. Next one is Sp3d3. You can understand easily. Here is one s orbital plus 3 p orbitals and 1 d orbital. 1 d orbitals are mixing. Here is 3 p orbital, 1 s orbital is intermixing. Okay, to form sp3dt, sp3d hybridization. Example is PCl5, phosphorus pentachloride. Phosphorus pentachloride, the hybrid. This one is a phosphorus. Here is chlorine. Here is chlorine. Here also chlorine. And this is the. And bond angle. What is the geometry? Trigonal bipyramidal. Trigonal bipyramidal pyramidal geometry, and bond angles are, bond angle is there are two types of bond angles, 120 degree and 90 degrees are present. 120 means this is the 120, this one is the 120, so all are same 120. Here is 90 degrees are present. That's why the trigonal bipyramidal and bond angle is 120 and 90 degree. Here is phosphorus. What is the electronic configuration of phosphorus? Phosphorus is 1s2, 2s2, 2p6, 3s2, 3p3. Here is one of the electron jumped from s orbital to d orbital. They are in the first excited state. Their s orbital is one of the s orbital jumped to the d orbitals. Here is d orbital, this one, and the 3, and this is 1 s orbital, 3 p orbital, 1 d orbital. They are intermixing to form sp3d, and this is the trigonal bipyramidal. Next one is the sp3d2. We can take sp3d2 sf6, f and f. Here also, what is the shape, what is the geometry? This one, octahedral geometry. Geometry is octahedral geometry, and the bond angle is 90 degree. Bond angle is 90 degree. Next one is a sp3d2, sp3d3. sp3d3 is if7. We can take if7, and we can take this one, pentagonal bipyramidal, and one of the fluorine. Here fluorine, here also fluorine. There are two types of bond angle, 90 degree. Another one is the 72 degree. This is the 72 degree, and this one is the 90 degree. And geometry is pentagonal bipyramidal, and bond angle is 90 and 72 degree. These are sp3d, sp3d2, sp3d3. Next one is the formula of hybridization. What is the concept of hybridization? Very important. They are asking actually in examination. That is geometry and bond angles are asking. And next, what is the formula of, there are two types of formulas are present in hybridization. Very simple formulas, remember. One is the hybridization formula, hybridization based on structure, number of sigma bonds plus lone pairs. For example, I am taking example water. These are the two lone pairs now. How many sigma bonds? 1 and 2. 2 sigma bonds, 2, plus how many lone pairs? 1 and 2. That is equal to 4. 4 means sp3, tetrahedral. Next one I am taking SO4 2 minus. SO4, this is the structure SO4, O minus, here also O minus. Now how many sigma bonds are present? that is sigma bond 1, 2, 3, 4. This is only sigma pi, sigma pi. This is sigma bond, 4 sigma bonds. 4 sigma bonds means sp3 hybridization. If you take CO3 2 minus, if you take CO3 2 minus, here also, here O minus, here also O minus. Now how many sigma bonds are present? 1, 2, 3. 3 sigma bonds means sp2 hybridization. This is the based on structure. This is one of the formula. Another formula is very important. Another one is the very important. That is Z is equal to, please write this formula. It is very useful. Now Z is equal to hybridization formula. Z is equal to of valency electrons on central atom, valency electrons on central atom plus negative charge, next minus positive charge plus number of monovalent atoms, monovalent atoms. What are the monovalent atoms? Hydrogen, fluorine, chlorine, bromine, iodine. These are the monovalent atoms. Now what is the hybridization formula? Z is equal to of valency electrons on central atom plus negative charge minus positive charge plus number of monovalent atoms. Now I am checking NH3. First example I am checking NH3. What is now write Z is equal to of NH3 I am checking. Nitrogen valency, what is the valency? It is belongs to fifth group, 5 plus number of monovalent atoms 3, that is equal to 5 plus 3 8. 8 by 2 means 4. 4 means sp3 hybridization tetrahedral geometry. Next one, H2O I am taking, H2O. Now Z is equal to of total number of valency electrons on central atom oxygen 6, number of monovalent atoms 2, that is also 4, sp3 hybridization tetrahedral geometry. Here is NH3, H2O, number of molecules we can take xenon F2 I am taking, xenon F2. Z is equal to of, here is xenon means 8 electrons in valency shell. Now number of monovalent atoms 2, that is equal to 5 means sp3d, sp3d hybridization trigonal bipyramidal. But according to VSEPR theory, valency shell electron pair repulsion theory, this is the linear. Next class we can explain that one. Xenon F4, that is Z is equal to of xenon is 8 plus number of monovalent atoms 4, that is equal to 12 by 2 means 6, sp3d2. sp3d2 means octahedral geometry. Next one is SO4 2 minus. Here is Z is equal to of sulfur valency electrons 6 plus oxygen is not monovalent atom, that's why take 2 minus means plus 2 added, that is equal to 8 by 2 means 4 sp3 tetrahedral geometry. We can take any molecule, we can tell use this formula. Z is equal to of valency electrons on central atom plus negative charge. If negative charge is there means add, positive charge there is there means subtract, number of monovalent hydrogen, fluorine, chlorine, bromine, iodine. Next examples also we can easily find out. CO3 2 minus and PO4 3 minus, and next one is xenon O2 and xenon O3. By using this formula we can easily find out the hybridization. Hybridization concept is very important. Last year 2021 NEET question they are asking geometry. Now we can use this formula. It is very important. That's Z is equal to half. Next formula is Z is equal to number of sigma bonds plus and lone pair. LP means lone pair. Use these formulas and you can easily, and these are the very important formulas you can remember while who are preparing NEET aspirants. Okay.